Everyone, today I'm gonna be solving this problem when I'm being asked to find the limit of open parenthesis 1 plus 1 over n close parenthesis to the power of n as n approaches infinity. N could be anything, n could possibly be x, n could be y, n could be anything. So n is just a variable, just for you to know. Here, if I go ahead and I try to do it, so let's have the limit as n approaches infinity of 1 plus 1 over n, the power of n. I end up with, I know that as n approaches infinity here, this number is going to get smaller and smaller and smaller until it's getting close to 0. So this, in a way, will go to 0. What about to this n? This n here. This n will go actually to infinity because it's actually growing all the way to infinity. And so what will end up happening here is that we have 1 plus 0 to the power of infinity. So I have 1 to the power of infinity, which is an indeterminate form. So when we see this type of cases where we're indeterminate forms, we want to use L'Hopital's rule. So how do I use L'Hopital's rule? I can come here and set this whole thing and say, okay, let's say that this whole thing is equal to, so it's a function. So let's say y is equal to the limit as n approaches infinity of 1 plus 1 over n to the power of n. So what I can do to drop this one n here, because that's the problem that I have, I can take the natural log of both sides. So I can take natural log of y is equal to the limits, of course, as n approaches infinity of the natural log of these things. So the n is going to drop down here. So I end up having n times natural log of what is inside, which is 1 plus 1 over n. Perfect. Now, if I try to take the limit, this will go once again to infinity. And then this, once again, the 1 over n will go all the way to 0 once again. So I end up with natural log of 1, which is 0. So I end up with another indeterminate form whereby I have infinity times 0, which is another indeterminate form. So I'm going to rewrite this in a way that I'm going to rewrite this whole thing in a way that I can use L'Hopital rule. Okay, I'm going to rewrite that now. So I'm going to end up having, I'm going to rewrite this n so that it comes in the denominator, so that I can take the derivative of the top and the bottom. That's what L'Hopital's rule says. L'Hopital's rule say that if we take the derivative of the top and the bottom, we can end up having the limits of what we're looking for. So once again, I have natural log of y is equal to the limits as n approaches infinity of natural log of 1 plus 1 over n over, if I want to put this in the denominator, that means that I'm going to have something like n to the power of negative 1, because this n to the power of negative 1 is the same as 1 over n. And if I have natural log of 1 plus 1 over n divided by 1 over n, this is the same as the keep chain flip, whereby I will end up having this changing into n over 1. So I end up coming back to my original function here. That was just to make sense of what I just did. So I'm going to keep it as 1 over n instead of n to the power of negative 1. So, that was the wrong thing here. I can erase this here. So, 1 over n. Once again, if I take the limit, this will go all the way to 0, and then this will go all the way to 0. 0 divided by 0 is once again an indeterminate form. So now I'm going to come now and use the L'Hopital's rule, whereby I'm going to take the derivative of the top and the derivative of the bottom. So if you look at this top part of what I have, natural log is a function. What I mean is that if I give it an input here of n, I'm going to have different results over time. So if I give it, I give n is equal to 1, so I'm going to have 1 over 1, which is 1 plus 1 gives me 2, so natural log of 2. And the same thing will go on and on and on. So it's a function. So natural log is actually a function, right? But what is happening inside also can be taken as a function, because 1 plus 1 over n can actually stand on its own, whereby every input that I have will give me a different result. So I have indeed a function. So this function here, let me put it in another color. 1 plus 1 over n is a function, and it is engulfed inside of another function, which is natural log of natural log, right? So with that in mind, when I take the derivative, I know that I have a function inside of a function, so I'm going to be using the chain rule. So here, what I'm going to do is I'm going to take the chain rule of this top one. So the derivative of natural log is actually 1 over whatever is inside of the parentheses. So I end up with 1 over 1 plus 1n. Amazing, right? And the derivative of what is inside here would give me, if I take the derivative of 1, that is 0. The derivative of 1 over n, this is the same as n to the power of negative 1. So I can use the power rule. So I can bring this negative on top in front here. So let me do it for you. So I can take I'm going to do it on the side actually. I'm going to take this derivative of n over 1, n to the power of 1, that's negative 1. So I drop the word negative 1, right? And then I have to subtract another 1 here. So I end up with negative 1 minus 1 gives me negative 2. So I end up with negative 1n to the power of negative 2, which is just the same as negative n to the power of negative 2, which I can rewrite it in a form of fraction. So I end up with negative 1 over n squared. Perfect, right? So I have got that, and I can put that back to my original equation. So I end up with minus 1 over n squared. And the same thing goes here, because I have 1n over n. And here, if I take the derivative, it will also give me negative 1 over n squared. 0 minus n squared, 1 over n squared, sorry. This will give me just negative 1 over n squared, right? So what happens next is that I can simplify those things that I just got. I can come here and simplify this and this one. I can get rid of them because they are the same on the top and the bottom. So my final answer here becomes 1 over 1 plus 1 over n, right? So if I take the limit, I'm going to rewrite it here. I have natural log of y is equal to the limit, the limit as n approaches infinity of 1 over 1 plus 1n. So this, remember, the 1 over 1n, if as n goes to infinity, it is getting closer and closer to 0. So this will go to 0. And what I end up having is 1 over 1, which is basically 1. But here's the thing. We know that natural log of y is 1. We don't know what y is equal to. So because of L'Hospital rule, what we can do is that we are going to take the Euler's constant to the power of this natural log, of y. And we know that natural log of y in this case is equal to 1. So our answer is actually equal to e to the power of 1, which is just e. Thank you so much for watching, and let me know if you're confused or anything doesn't make sense. Thank you so much. See you.